Welcome back. In this video, we will discuss about psychometric properties, and we are going to analyzing air conditioning processes, and particularly heating, cooling, humidification and dehumidification, adiabatic mixing of two stream, as well as the working of a cooling tower. All these comes under the chapter of psychometrics, which is the module number 4 of applied thermodynamics. First, we should understand what is the psychometric process. The processes affecting psychometric properties of air are called as the processes, psychometric processes. Okay, there are different processes are there. Mainly, we used the following processes. Something like mixing of stream, sensible heating, sensible cooling, cooling and humidification, cooling and humidification, heating and dehumidification, as well as heating and humidification. These are all the 7 processes that a psychometric processes involves. And to learn more about this, the following animated video, the video will help you to understand this one. Just watch that video, that will give more clarity about this. That gives more graphical or pictorial representation for you to understand how these processes are carrying out inside a psychometric chart. Okay, after that we will meet for further discussion.
Sensible heating. Sensible means we can sense the change in temperature. So, only increase in temperature is termed as sensible heating. There is no change in specific humidity of air. The process can be plotted on psychometric chart as shown. From 1 to 2, the dry bulb temperature changes from T1 to T2, and specific humidity, that is horizontal line, is constant. Here, relative humidity increases from phi1 to phi2. The heat added can be calculated by calculating change in enthalpy shown in the figure. The process of sensible heating can be done by using a heating coil through which hot water is circulated. Air at temperature T1 passes over the coil and its temperature increases to T2. Next, sensible cooling. It is decreasing temperature of air only without changing specific humidity of air. It is simply opposite of sensible heating. The process can be shown on psychometric chart from 1 to 2. It is a horizontal line directed towards left. In the process of sensible cooling, the dry bulb temperature decreases from T1 to T2 and relative humidity decreases from phi1 to phi2, but specific humidity is constant. The process of sensible cooling can be done by using a cooling coil through which chilled water is circulated. Air at temperature T1 flows over the cooling coil and its temperature decreases to T2 as shown in figure. The heat removed can be calculated by calculating change in enthalpy from the chart. Next, humidification. It is process of addition of moisture into the air without changing dry bulb temperature. The process is shown in psychometric chart as vertical line directed upward. In humidification, the specific humidity increases from W1 to W2, whereas dry bulb temperature remains constant. Here, the relative humidity increases from phi1 to phi2. The process of humidification can be done by spraying water at same temperature that of air into the air as shown in figure. Next, dehumidification. Dehumidification process can be shown on psychometric chart by a vertical line from 1 to 2 pointing towards downward as shown in figure. Here, the specific humidity decreases from W1 to W2, whereas dry bulb temperature remains constant. In this case, relative humidity also decreases from phi1 to phi2. Dehumidification process can be done by using chemicals like calcium chloride or silica gel. Air is passed through slabs of these chemicals which absorbs moisture from the air as shown in figure. Next, cooling with humidification. In this process, the dry bulb temperature decreases from T1 to T2 as well as specific humidity increases from W1 to W2. The process can be shown on psychometric chart by an arrow pointing from 1 to 2. Next, cooling with dehumidification. In this process, the dry bulb temperature as well as specific humidity decreases The process can be shown from 1 to 2 and relative humidity in this case increases from phi1 to phi2. Next, heating with humidification. In this process, the dry bulb temperature increases from T1 to T2 and specific humidity increases from W1 to W2. In this case, the relative humidity increases from phi1 to phi2. The process is plotted on psychometric chart in the slide. Next, heating with dehumidification. In this process, the dry bulb temperature increases but specific humidity decreases. The process is plotted in the chart from 1 to 2. So these are different psychometric processes. In summary, let's have a look at all these processes and how to plot them on psychometric chart. Here, for example, heating is indicated by a horizontal line pointing towards right. On the opposite hand, cooling is indicated by a horizontal line pointing towards left. Humidification and dehumidification processes are indicated by vertical line. Humidification pointing towards upward, whereas dehumidification pointing towards downward. Combination of these processes can also be plotted on psychometric chart. In practice, combination of these processes occurs in HVAC systems. For example, heating and humidification can be indicated by this line. Similarly, cooling with humidification can be shown by this line. Similarly, cooling with dehumidification by this line and heating with dehumidification by this line. So these are psychometric processes.
Hope this video might have given a proper clarity about all these processes and how it involves, as well as how we can represent the same in the psychometric chart. Now let us see what is a cooling tower. Cooling tower is cooling towers are primarily used for heating, ventilation and air conditioning in industrial process or industrial purposes. Cooling tower mainly used to provide a cost effective and energy efficient operation of the system where it needs to be cooled. And you can see these are all the typical cooling tower where industrial industries are using real time. And one more video I am planning to show to you, which will give how a cooling tower works. And this is the animated video, just watch that, that gives more clarity about this cooling tower.
The cooling tower is a device for cooling large quantities of water, which circulating in a water recycling system. Circulating water system is a system in which water is used as the refrigerant for cooling the heat exchange equipment. The use of cooling towers saves natural water from 25 to 50 times compared with once through cooling and prevents thermal pollution of water bodies. After cooling, the main volume of recycled water fed back into the process cycle. Usually no more than 5% of water is lost to evaporation, drip loss, leakage, and discharge into a blow-down system. Losses are replenished by fresh water makeup. So, how is the cooling tower working? Water in cooling towers is cooling by evaporation of water in the stream of atmospheric air, the heat transfer by contact with air. Hot water from the various sources such as machines or heating processes flows through pipes to the distribution system of cooling tower, which produces even water distribution to all the area of fills by the spray nozzles. On the fills, the water film is formed from the surface of which evaporation of the water and encounter airflow. Then larger the surface area of the fills, the more intensive is the evaporation of water and the more efficient is cooling tower. Evaporation is accompanied by expenditure of energy required to convert liquid to vapor. Humidity of the air is increasing when water evaporating. With the help of the fan is fed a steady airflow with low humidity. The air passes through the fills, saturated with water vapor. The water cooling efficiency of the fan cooling towers may be controlled by varying the supply air fans, changing of fan speed. A theoretically ideal loss on work to convert the water to steam. The limit of the cooling water in the cooling tower is the temperature of the outside air, wet bulb temperature. In practice, The limit of cooling is the temperature of the humid thermometer of +3 degrees Celsius. Operating a cooling tower emits air saturated with water vapor and containing water droplets with size of 100-500 micron. To prevent entrainment of water droplets above the water distribution system is installed a drift eliminator. Cooling water moves down and flows into a catchment tank, and then the pump is supplied to the technology.
Hope this video might have given the proper clarity, proper working principle on how a cooling tower works. And that's it, guys. That is the end of this. And with this, we will close this video, and we will meet in the next video. Till then, bye bye. Take care and be safe.